Dudora KONSULTS presents Mathematics Revision Preparatory Classes with Instructor, Mr. Sarumi Olugbenga. Kindly like, share and drop your comments below. Thank you for watching.
We want to review cumulative frequency curve, and you know that under cumulative frequency curve, there are three basic things that should be behind our mind. One, you can use cumulative frequency curve to find quartiles. You can use it to find percentiles. You can use it to find decile. Yes or no? Yes, sir. Quartiles, when you say quartiles, there are about 5 different quartiles that should cross your mind. The lower quartile, the middle quartile, the upper quartile, interquartile range, and semi-interquartile range. All this we have discussed before. Yes or no? Yes, sir. We know that quartiles is the first quartile, which is the same thing as the lower quartile, is 25% of summation F. You will agree with me that the first quartile, which is Q1, is 25% of summation F. The second quartile, which is Q2, and is also middle quartile, is also the median. Yes or no? Yes, sir. So if a question under cumulative frequency curve asks you to, using the graph above, determine the median, it's saying use your Q2 to find the median. That is, use the formula for middle quartile. And that would be 50% of what? The third quartile, which is upper quartile, Q3, is 75% of summation F. We know that the fourth type of quartile is interquartile range, IQR. That's Q3 minus Q1. Then I have SIQR. Obviously, that's semi-interquartile range. And that is half of the Q3 minus Q1. Am I still communicating? Yes, sir. Okay, this is information on quartiles, which we have treated in the past. Information on percentile. You know that for percentile, you know that if I ask you to percentile now, the white percentile is the same thing as y over 100 times summation F. That is 28th percentile should be 20 over 100 times summation F. Obviously, the value that corresponds to this is what we are talking about. Okay? 3. You also know that deciles is part of what we should know. If I'm at the kth decile, is the same thing as k over 10 times summation F. E.g., the fourth decile should be 4 over 10 times summation F. This is telling us that these formulas are things that we will need, and we should please go back to all what we have said on them before to actually refresh our memory. Let's take just a question on cumulative frequency curve to actually look at applications of these formulas. Can we swing into action? Let's write. The table shows the distribution of marks scored by 50 students in a test. The table below shows the distribution of marks scored by 50 students in a test. I'll put the table on the board. Please, let's write very fast so that we can manage our time very well. Under the table, the first question says, construct, that's A, construct a cumulative frequency table for the distribution above. Construct a cumulative frequency table for the distribution above. B, are we good? Yes, B, draw a cumulative frequency curve for the distribution. Draw a cumulative frequency curve for the distribution. C, use the curve to estimate the 1, interquartile range. 2, percentage of students who scored more than 66%. Use the curve to estimate the 1, interquartile range. 2, percentage of students who scored more than 66%. Okay. Can we start now? Are we together? Now, what is a cumulative frequency table? Cumulative, this is cumulative frequency table. Please, it is important for us to note that it is not all the time your examiner will ask you to present a cumulative frequency table or draw a cumulative frequency table, but it is all the time that you are expected to do it. Is that English clear? Yes, sir. For this question, they are asking us to do it. But it may also come your way the next exam you want to write. They may be silent about it. When they are silent about it, it's a trap. They will not tell you to do it, but they will allocate marks for it. So, even when the question did not say it explicitly, it is your responsibility to show it, whether it is said or not. Am I communicating? Yes, sir. Great. Can we, for a cumulative frequency table, it has 4 columns, basically. And these columns are the class interval, which will be represented by marks here. The frequency, the cumulative frequency, and the class boundary. And the class boundaries. Please, your cumulative frequency table must have 4 columns, and these also attract marks. For the first class interval, you repeat what is given to you, 1 to 10. Yes, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, and 81 to 90. That's the interval given to us. Then we have frequency allocated to each interval. This is 1, 3, 5, 8, 1, 3, 5, 8, 12, 12, 10, 5, 4, 2. What is the total? I think they said 50. Cumulative frequency. How do we get cumulative frequency? You repeat the first one, and you add it diagonally. 4, 9, 17, 29, 39, 44, 48, 50. A situation that your last cumulative frequency value is not equal to your total frequency, then you have done a wrong thing. A situation where the last cumulative frequency value is not equal to the total frequency, quickly go and recheck these values or recheck your total as much as possible. Okay? Class boundary. Oh, for class boundary, I think I've said it to my students, but I will need to re-emphasize that also. Class boundary, when they are whole numbers, it's easy. It's plus or minus 0.5. You have two types of class boundary. You have the lower class boundary and the upper class boundary. When they are whole numbers, when your intervals are whole numbers, you use plus or minus 0.5. So the lower class boundary here should be 1 minus 0.5, that's 0.5. And this will be to 10. Is it not? Yes. Is there any error there? No. You are reducing this by 0.5. You are increasing this by. Is that not what class boundary is? For what? For whole numbers intervals. Please, that's it. This is 20.5 to 30.5. This is 30.5 to 40.5. 40.5 to 50.5. 50.5 to 60. 70.5 to 80.5. 80.5 to 90.5. That's our class boundaries. But if, for one reason or the other, the interval changes to, instead of 1 to 10, if you have 1.5 to 1.9, how do you get the boundary of the boundaries of this? This is not whole number. Is this whole number? If this is the max, how do you get class boundary for this? 1.5 to 1.9. Now it will change from plus or minus 0.5 to plus or minus 0.05. Because already when it was whole number, we were using plus or minus 0.5 because we were using something of one place of decimal. 0.5 is how many places of decimal? 1. Is there any place of decimal here? No. But here already, the max is already at, the max here is at what? One place of decimal. So you cannot use plus or minus 0.5 again because 0.5 is also one place of decimal. You must increase it. And that is why we are using plus or minus 0.05. So the class boundary here should be what? 1.45 to 1.95. If 1.5 minus 0.05, what is it? 1.95 plus 0.05, what is it? Okay, please, let's take note of that too. Let's take note of that. And before it escapes my mind, please, let's note, you have the material. Let's note the question of your GC past question, 2018 number 3. Write it down. 2018 number 3. Write it down. It will actually tell you what I'm talking about. So when you are reading, try and check. That question is also a statistic question, but it's an histogram problem. And the interval there is something like this. It is not whole number. Are we still together? Yes, am I on the same page with you? Yes, please, I don't want distraction there. Can we move to the next thing then? Yeah. Okay. we can use this space now for cumulative frequency curve. Do we place our y-axis in the middle? Or do we place our y-axis in the middle? What do you plot on the y-axis? What do we plot on the y-axis? Cumulative frequency. What do we plot on the x-axis? Class boundary. Basically, it should be upper class boundary. Upper class boundary. Were you given scale? It is also the type of graph that you have to choose scale by your. That is why you must understand scale very, very well. Let's look at cumulative frequency. The lowest is 1, the highest is 50. The lowest is 1, the highest is 50. If I'm taking somebody's graph as a case study, and I'm looking at it very well, if I'm looking at that graph very well, the lowest is 1, and the highest is 50, and I want to accommodate 2 centimeters. If I say 2 centimeters to 10 units, or 5, we can use 5. We can use 5. This will be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. We are good. We can use 5. So on the y-axis, my own scale for y-axis is 2 centimeters to represent 5 units. Right? 2 centimeters represent 5 units on the y-axis. And on the x-axis, you don't have a problem with that because we are fixing those values directly. Can we place 2 centimeters to represent 5 units? And I will go this way. This is my 2 centimeters, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. We'll be able to manage my space. Then, for x-axis, I have recommended that you leave the first 2 centimeters. You remember I recommended that? Leave the first 2 centimeters. And you are starting, I've told you, I should not, we are starting directly from the first upper class. Why did I say that sometimes ago? I said that because there are sometimes this thing will not be 1, it will be 0. So if it is 0, this will be minus 0.5. We have discovered that student has problem with managing the starting point of negative. So we now saw a good point to leverage on when we discover that you can also draw cumulative frequency curve, even avoiding the first value of the lower class, the first value of the class boundary. So you can start principally from the first upper class boundary. And that means my values here will look like this, 10.5 to 20.5 to 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5. Are we on the same page? Okay, can we take it now? When it is cumulative frequency is 1, what is the interval is from 0.5 to what? They are sleeping. When it is 1, how many O's gives you 1 here? 2. Thank you. I like that. 2. With what we have done, the first 2 graphs now, you should not have problem with scaling. 2 tiny O's will give us what? 1 here. So I want to believe this is my 1, and this is from 10.5. If you just be hanging, it will be hanging in that space to start. The next one is from 10.5 to 2.5, which is what? 4. 4 will be 2 O's down. Are we together? Yes. 2 O's down, and it will be landing on 20.5. Okay? The next one is 20.5 to 30.5 is 9. 9 is 2 O's down from 10. Okay? 30.5 to 40.5, that's 17. 17 will be what? 2 O's up from 15. Oh, yeah, 4 O's. 4 O's up. Yes. 4 O's up. Okay. What's the next one? 29. 2 O's down from 30. Shay? $39. 2 O's down from 40. $44. 2 O's down from what? 45. $48. 2 O's down from where? 48. 4 O's down. 4 O's down from where? From 50. 4 O's down from 50. Because 2 O's gives you what? 1. Then 90.5, that is 90 or 90.5, that is our 50. All right. It is at this junction you will now have to join your points together. Please, you know how to join curve now. You are not using your ruler to join curve together. And it is from the first point that you are starting your curve, not from any other point. This is the way your curve should look like. You have your curve already. Can I see your hand? Oh, that's a good one. It's a good one. So, like I said, those dotted lines, they are not necessary. Okay, can we take the first question? Use the curve. Please remember that you need to write your scale. What is the scale for this graph? 2 centimeters represent 5 units on the y-axis, and 2 centimeters represent is a lie. 10. Good. 10. 10 units on the y-axis. We need to. What's the difference between 20.5 and 10.5? 10. 10. We need to be very smart. 10. Yes, madam. Use the curve to estimate the interquartile range. What is interquartile range? Q3 minus Q1. Q3 here will be 75% of summation F. We need to get this is 75 over 100 times summation F is 50. Total frequency is summation F. What's this? This gives you 37.5. That is not the answer. You are expected to locate 37.5 on no. You locate 37.1 on the graph. I told you, locate 37.1 on the graph, you get the value of Q3 first. You go to Q1, locate the value again, before you now find the difference. That is what we said. So what is 37 point? This is 30. This is 35. How many O's there? You roll. No. Okay, 5. Yes, 5. A good one. 5. Count 5 O's after 35. I want to believe this is my own. Wherever it meets with the curve, trace it back to x-axis and read this value out. Somebody should help us. And please put Q3 here. Put Q3 there. 58.5, it will be percent now. Because values that are here, they are values in percentage. Yes? Q1 will be 25% of summation F. That's 25 over 100 times 50. And that is 12.5. Yes or no? 5. Where do we locate 12.5 now? 5 boxes after 10. Yes or no? And write Q1 here. Whatever this gives you is your Q1. Can somebody tell us the value there? 30. Are we still looking or trying to get the exact value? How do you read value here? Each O is what? 1 now. So there should not be issue with that. What's your value here? 35.5. Okay. If it is 35.5, then interquartile range, is that not the question? Interquartile range should be Q3 minus Q1 And that will be 58.5 minus 35.5. What's that? Eh? That will be 23%. Please, do we now remember that you don't just subtract. This is not your value. You have to get the actual value of Q3. After getting this, you must go and read the value on the graph. I hope I'm communicating now. Yes, can we move forward, madam?
Yes. Percentage of students who score more than 66%.
Percentage of students who score more than 66%. Where do we have percentage? Where do you have 66% here? Is it on the y-axis or on the x-axis? What are they asking you to get? Number of students. It is number that you turn to percentage now. Yes or no? How many students are there? 50. Thank you. But 66 now. We'll locate 66. 66 is the mark of the student. The mark reflects where? This is where marks is reflecting. Number of students is reflecting where? On the y-axis. So can we locate 66 now? 66 will be 6 O's after 60. Is that not? Yes, that will be 66.5. So, so instead of 66.5, can't we take 65.5? Or we can decide to stay in between 65.5 and 66.5. So locate the middle point. Try and locate the middle point of that hole. I want to assume that this is my own middle point here, and I'm moving up. And after touching that curve, I will have to come here . The number of students that scored what? 66 and above, Abi. More than 66. Hello, you better look up. You better look up. If you are still looking down, you may misinterpret that question. All these values are, look at these values. Are they above 66 or below 66? When you trace this thing up and come here, the value here, if you look at my hand, the value here, coming this way is to the values here. So the number of people here are the number of students that actually scored these values. The ones that score more than 66, this is more than 66. Yes or no? Yes, going up and coming here, so it should be above here. So this interval, if this is where you are coming out, if this is where your 66 came out, the interval that's called above 66 and above should be this 9 and above. If it is just 66 and below, these are the number of people. Are you with me? Yes, so whatever you have here, subtract from 50. What do you have? Eh? What do you have here? 42. So that's the number of students scored more than 66% should be 50 minus 42, and that is 8 students. But the question did not ask for number, it asked for percentage. Check, the question did not ask for number, it said percentage, so you must be careful. So percentage now of students should now be 8 over 50 times 100. That's 16%. Any question? Any question? Class? Any question? Any reaction? I hope you remember I said they can also decide to lump probability to cumulative frequency problem. This question, if I say what is the probability of students that score more than 66%, it's still the same thing as 8/50, but you will now reduce it to the lowest fraction. What is that probability? 8/50, 4/25. That's the probability. Proportion. What's proportion here? Yes. The proportion of students. Can you see what is coming out from there? The proportion of students that scored more than 66%. What's that? It's still the same thing here. It's still because proportion is showing the same thing as probability. It's 8/50, which is like 4/25. If the question changes and said how many students scored how many students scored? If it is just as say how many students scored they did not score, they scored maximum of 66%. 42. 42, because that did not score above. How many students did not score above the 66? That's 42. That's 66 and below. That's 66 and below. But if you have at most, okay, how many scored at most 66%? At most. At least 66%. 8. These are ways by which they can change that question and still saying the same. Am I communicating, class? Please, I've given you something that will call your attention to histogram. This year, we may have either cumulative frequency or histogram. Both should be dealt with. For listening, thank you for giving us your time. And I want to give you the assurance that if you use all that we have said, great excellence will be your portion. Thank you, and the Lord bless you.